Hello, today we are going to discuss whether a polynomial is even, odd, or neither. We're going to talk about it graphically first, and then we're going to show this algebraically. So a function is even if it has symmetry about the y-axis. And so what we want to think about is if it were to reflect across the y-axis, then that would give a mirror image or the same result. And so a function is odd if it has rotational symmetry about the origin. So that means that if we were to rotate 180 degrees about the origin, then that would give us a similar or the same picture. And then if it is neither one of those, then it is going to be neither. So one quick thing about an even function is that we need to look at the y-axis. And so we want something that's going to be reflective on both sides, where this side would reflect over to the other side. So that would be even. For something that's odd, we want it to pass through the origin. Let's get one that passes through the origin. And so if we were to take this and we were to spin it, 180 degrees like that, or if you were to flip your paper over, your head upside down in this case, you would get the same result. If it doesn't do either one of those, then it's neither. So looking at these, what we want to do is we want to check whether it's even. So if we are down the y-axis, we can see that that would reflect across that. And so we would say that this is an even function. And then if we were to spin it, so if we were to take the whole thing, and let's erase that part. So if we were to spin this upside down, we're going to get upside down parabola, which is not the same. So this is not odd, so we just have something that is even. Okay, for the next one, same thing, we test whether it's even. If we go straight down the y-axis, we're going to see that that vertex doesn't sit on the axis, which is a requirement for us to be an even function in this case, so it's not even. And then if we were to spin that, or if you were to turn your head upside down to see the screen, you will see that that's going to open upside down, so that is not even, and so this is going to be neither. Looking at the next one, if we split this down the middle, down our y-axis, that is not going to reflect over because this part is going to end up down here, so we don't have something that's even. So we'd say it's not even, but if we were to rotate this 180 degrees, meaning we're going to flip it all the way around, we still get a line that is like a positive slope going up and to the right that passes through the origin. So that's the same as if you do it real quick as that. So then we would say that that is an odd function. Next one, same thing, we go down the y-axis, and that's not going to reflect over because we were going to get something over here, so it's not even. And then if we flip this 180 degrees, it's not the same thing, it opens down now. So we would say that this is neither. This one, if we go straight down the y-axis, then we're seeing that this is going to reflect over, so we do have symmetry. So we would say that this is even. If I flip this over, we're going to have it facing up now, so it's not the same. So we are just even. And then lastly, if we look at this one, if we flip that across, that is going to be not even. And then if we look to spin this, our y-intercepts is where you can look at it. So our y-intercept here in this case is like +6. If we go here, it's -6, so it's not going to be odd. So we would say neither for this. Okay, so that's how we want to look at these graphically. If we were looking at these algebraically, what we want to do is plug in -x. For even or odd or neither, you're going to plug in -x. There's no like special case for one or the other. And if you get the original function, then you have something that's even. If you get something that is the exact opposite, that means that if every net sign is changed, then it is an odd function. If you don't get either one of those, then we would say they're neither. So looking at these, what we're going to do is, like I said, we're going to plug in f of -x. Using parentheses, we're going to substitute that wherever we see x. Now you need to know order of operation, so we're going to say this is really like negative x times negative x minus 4, and negative x times negative x is positive x squared minus 4. So nothing should be changing, no values, no exponents or anything like that. The only thing we should be paying attention to is our signs. So here we have the same sign as we had here, and here we have the same sign as here. So we have the exact same function. So these two are the same. So f of negative x is the same as f of x, so we would have something that is even, based off of what we said on the previous slide. So we get the original rule, then something is even. Okay, if we have f of x equals 3x plus 1, so if we plug in negative x, we get 3 times negative x plus 1. So we would say f of negative x is equal to negative 3x plus 1. And looking at that, our signs, we have negative and negative, so we should know it's not even. And then we have a positive and a positive. So we don't have the exact opposite. Opposite meaning all of the signs flipped. Only the first term, the leading coefficient, flipped. So then it's not odd, so we would say that this is neither. We would need something to look like negative 3x minus 1 in order for that last one to be odd. Okay, if we look at the last one, same kind of deal, plug in negative x. There's no special case or anything like that. Just plug in negative x. We get 2 times negative x squared minus negative x plus 14. And so this is going to be negative x squared is going to be positive x squared, so we get positive 2x squared. Negative negative x makes positive x plus 14. Okay, so looking at our signs, we get a positive 2 and a positive 2. So we should know that we're not odd because we haven't switched signs. We have a positive x and a negative x. So now we should recognize that we're not, the first one, 2's and 2's, we should recognize that we're not even. The positive x and negative x should show that we're not odd because not everything has flipped. So since not everything is flipped, then we are flip signs, we are neither in this case as well. Just to show you a quick example of something that we might see as well, is if we had f of x is equal to x to the 5th minus 3x. So if we wanted to find this, we could find f of negative x. Same thing we're trying to show on the last one is if this is even or odd. So we would say negative x to the 5th minus 3 to the negative x. And so anything negative to an odd exponent is going to be negative. So we're going to end up with negative x to the 5th like so. If you wanted to write it out as like negative x times negative x times negative x and so on, you can see that. And then this is going to be positive 3x. So looking at the signs, we have opposite for the first one, so we should know it's not even. And then we have opposites for the second one, so everything is opposite. So this is really f of negative x is equal to negative f of x. So that means that this is an odd function. Okay, I know there's a lot of x's going on, but all you are going to do is all you're paying attention to is the signs. Nothing else should change. So in this video, we have found graphically and algebraically how to show whether a polynomial is even, odd, or neither.